Okay, on to the Energy and Power Lab. Numbers 10 through 15 and 19 through 27. Number 10 asks to use 1 kilowatt hour of energy. How many hours would a 10-watt bulb have to be on? And show your work. And what I did was copied and pasted up above where it was walking through the explanations here. It says 1,000 watts times 1 hour equals 1,000 watt hours, or 1 kilowatt hour. Okay, because kilo means 1,000. Okay, so 1,000 watt hours is the same as 1 kilowatt hour. And down at 10 then, I copied and pasted those two lines so we can kind of follow along with those as a model, and we'll write the equation we want. Okay, so we want to use 1 kilowatt hour. We have a 10-watt bulb. We want to know time. Okay, so our watts are here. So in our case, this is going to be, and let me just 10 watts. It's going to bold it, and I guess I can see that. It might make it easier to tell what we're doing. Okay, so 10 watts times, okay, this is 1 hour up here. This is what we're solving for, though. We're trying to figure out how many hours. Usually you solve for x, but in this case, we'll have two x's right together. It looks strange, so I'm just going to put question mark number of hours, and equals, it says we're going to use 1 kilowatt hour of energy. So kilowatt hour. Okay, so now we want to solve for the question mark. We want to divide both sides by 10 watts, but we have different units right now. We have watts on this side. We have kilowatts on this side. So let's just change this to watts. So kilowatt is 1,000 watts. So we'll just rewrite this. 10 watts times question mark number of hours equals 1,000 watt hours. Now we're going to divide both sides by 10 watts. So what we're left with is number of hours. So division, and we'll go over here and divide by 10 watts here. I guess we still need that bold. It looked better anyway. Watts. Okay, and on this side, we're also going to divide by 10 watts. And now these cancel. They're top and bottom, so we can do a cancellation there. Let's see. Can't see my... Yeah, I'm not seeing something that I need here. We're going to get rid of that. I know, I'll just unbold it. Or I could just... Let's do this. That. Okay, so those are canceled out. And then here, divide both of these by 10. So it's going to be like taking 0 off of that. 0 off of that, which is 1. 100 over 1 is 100, so we can get rid of that. And we're left with number of hours is 100. I forgot to get rid of the watts, though. Okay, so we're talking about 100 hours. I'm supposed to cancel out the watts also. Okay, and then 11 is a little different here because you're going to the DOE side. And you're going to be using, if you scroll down here, there's a nice calculator here. and it doesn't look like much at first because it takes a while to load. So to save time on the video, I already have that ready to go. Oh, because every time you go back to it, it has to reload anyway. Okay, let's take a look at these questions while we're waiting for that. Hopefully that'll work out for us. I'll just pause if I need to. Okay, so it says 3 items from the DOE site have been listed in the table below using the DOE site in your own calculations, because it does calculations, but we have a different number that we're using that it doesn't have, I think is the problem, if I remember right. So you complete the table and the calculations to get the answers. Okay, so down here, ceiling fan, clothes washer, clothes dryer. I think this one is ready to go. Okay, so let's look at ceiling fan. Drop down menu here, ceiling fan here. Okay, it says the wattage, it tells you the wattage. Yeah, we're going to use a 14 cents per kilowatt hour utility rate, and that's why this calculator won't work. For our case, 35 watts, I think that's the number we need. Let's go back here. Okay, 35. I think that was just watts, not kilowatts. Kilowatt hours. Okay, I just double checked, and 35 watts makes sense. So we'll go back here. Okay, 35, but this is asking for how many kilowatts. So it's 35 watts. And we're going to have to move the decimal point 3 places to the left because we're going to have fewer kilowatts. So 1, 2, 3, and the decimal place goes here. Okay, so 35, move the decimal point over 3. We could put a 0 here too if we want. Okay. And now it says to use for the hours per year column, which is next. These are the appliances and numbers. So the ceiling fan is going to be 4 hours per day, 100 days per year. Okay, so one way to look at this logically is to put in for the ceiling fan here. Let's just do a calculation. So it's going to be down here. So 4 hours per day. I'm going to write it this way. I'm going to put underline and down below on the next line. That's per day. And multiply that by 180 days per year. 180 days per year. Okay, I give up. I'm going to change those so they match. So what we're going to be doing is these cancel out, top and bottom you can divide by the same thing. And what you're left with is 4 times 180 hours per year. So that comes out to be 720 hours per year down here. Okay. For kilowatt hours per year, these get offset when you do this like I'm doing it. Kilowatt hours per year, you're just going to multiply kilowatts times hours, and you get your number here. Then multiply that by the 14 cents rate that we were given, and that'll be the amount, that'll be the cost per year. And you do that for the other two also. Okay, and that's the kind of thing that you'll be doing as you work through the rest of this also. So try now, after I've shown you this much, and see if you can go ahead and do the rest of this. You'll have a couple of calculations here, one for air conditioner, one for water heater, and then you'll have to figure out if $60 on a water heater timer is worth getting when you look at those prices that you end up with in your answers. Okay, so down here at 19 through 27, they aren't all math, so that's probably a good thing. 19, I don't remember this looking like this. Something happened with all, I know. When I added in extra lines for our calculations, I've offset some, some of this here at number 19. So number 19, if instead of biking in the desert at night, Professor Jeff biked for 1 hour on the incredible invention, he would have produced how many kilowatt hours of energy? But it tells you here, here's your calculation. And what it's talking about is this post here, so you want to make sure you've seen that. Okay, and then answer the question. And you'll look at the videos, listen to the numbers, and see if you can answer those questions. Okay, and the rest is more just thinking about what you've learned, thinking about what you know, and putting it all together here. And the Facebook claim, make sure, I have a feeling maybe some people skip this, and it is interesting, and it really helps to have seen that, to know what they're talking about down here at 24 in the Facebook claim. Okay, and then down here, okay, so our very own CGCC campus solar panels. Okay, so you want to pay attention to the numbers up here. And this tells you, you're looking at the panels here, and you want to see how many sets of 35 panels there are here. Okay, I did misspeak here. Read carefully, I'm jumping around. And okay, you want to look at the solar farm at this link, and you zoom in. This shows one set of the solar arrays. This has 35 panels. And so you want to count on this image at this link and see how many sets of 35 panels you see. And it gives you a hint here. So if you know, you might know that you're on the right track. Over 80, but less than 1,000. And so you calculate the total number of the panels, the photovoltaic panels. And then you have a little math to do down here. And hopefully after what we've already done above, you'll see the pattern and be able to get those numbers. If not, let me know.